My name is Arthur Falls. I'm the Director of Communications at the DFINITY Foundation. DFINITY is a decentralized alternative to Amazon Web Services cloud hosting solutions. If you're interested in learning more, please visit DFINITY.org and you'll find our social and community channels on there as well. We'd really like to have you join our community. So my name's Arthur Falls. I'm the Director of Communications at DFINITY, or I should say the DFINITY Foundation. In the past, I've been in blockchain for 6 years. I've been making podcasts and as an independent journalist for the last 4 years. That's how I got into blockchain. You'll see that on this slide, there is no logo. And the reason that there is no logo is that this is a presentation not about a project. It's a presentation about business needs, technology, and then a vision for combining technology to solve, to provide a solution for these business needs. Blockchain is one of these technologies, but it's only one, and it's been around for 10 years, and focusing on blockchain today is to ignore 10 years of well-funded, concerted research into computer science. Today we are going to talk about the needs of businesses on the internet. We're going to talk about emerging technologies that address these needs and the vision of DFINITY, which is the internet computer. As I said before, blockchain is only a very small part of the changes that are coming to the internet and the world. And the way that we see these changes occur is going to be influenced by business needs and the other technologies that are available at the same time. Business needs and technology. Blockchain is just another technology. So, what are the needs that businesses have on the internet today? There are two. Protection from data theft and hacking, and protection from something called platform risk. Just two. Just two needs. So, the need for protection from data theft and hacking, Maersk was the biggest, or is the biggest logistics company in the world. And they suffered a ransomware attack that destroyed their entire information infrastructure. So they lost all data and they had to use for 10 days paper-based systems. They lost basically all of the goods that they were shipping at the time. 17% of all goods that were being shipped around the world at that time were literally just lost for 10 days. And it took, in some cases, 6 weeks to find it. So from a study of the year 2017, the cost of the increase in expenditure on cybersecurity over the year 2016 was 22.7%. However, we saw a 27.4% increase in cyber attacks and hacking incidences. So we're spending more and things are getting much worse. Platform risk. The more external businesses you rely on, the more things that can go wrong with your business. This is a basic rule of business dependency. So examples of platform risk. Data theft and data loss from hacking. This is what happened to Maersk. Competing business interests. This means that a business that you rely on might, for some reason, begin to compete with your business and then is no longer incentivized to help you. For example, if you are selling goods on eBay or Alibaba, you rely on, this is autobiographical, you rely on eBay, a logistics company, and PayPal, which are all separate businesses that don't really care about you very much. They might decide to compete with your business and so stop serving you. Businesses that you rely on can just go out of business, and then suddenly you don't have the service that they were providing you anymore, and that can disrupt your business as well. And then you can have interoperability problems between software systems that lead to disruptions in communication within your business systems. So we have seen the Maersk example. Maersk lost some goods for up to 6 weeks. So there were businesses relying on Maersk to deliver their goods that were not able to do business for 6 weeks because Maersk had lost all of their goods. And I mean, that is an example of your business can be hacked, but then also the business that you rely on to deliver your goods can also be hacked. So there's 2 opportunities for your business to be disrupted by hacking. So a perfect solution, and I'm moving a little bit quickly here because we're translating, would not be owned by anyone. It would be hack-proof. It would never go down. It would always be available. It would be very effective at interoperating with systems that are built using it, and would have very few humans involved. And the reason we don't want humans is that all of these problems are human problems. And also, humans are extremely expensive. Those are the business needs that we've just looked at. Now, the technologies we have to solve those business needs, or to provide a solution to those business needs. Blockchain for secure data storage, everyone's familiar with that. We don't need to talk about it. Random beacon is a way of securing and coordinating a large network of computers very cheaply. This is the opposite of proof of work, which is extremely expensive. WebAssembly is a universal standard for software that will run anywhere. It was co-developed by Google, Apple, Microsoft, and the Mozilla Foundation. It is in everyone's phone. It is on everyone's laptop. And it means that you can write a piece of software and run it on a Windows, Linux, Mac, laptop, or an Apple phone, or an Android phone. And the vision of DFINITY is to combine these technologies into a single platform that we call the Internet Computer. And the Internet Computer is unowned, hack-proof, has 100% uptime, facilitates interoperability, and minimizes reliance on humans. So we're very familiar with blockchain, so we don't need to dwell on it. It's useful because it gives us a verifiable common system of record for a network of computers to coordinate around. Random beacon technology is more interesting. So proof of work is a way of generating randomness in a network of computers. It is essentially a lottery. And every time you hash of the block, you essentially get a ticket in the lottery. You get a chance to create a block. But as we know, it's very expensive to run the lottery that is proof of work. By having a random beacon that is a source of randomness built into the network that is very cheap, we get to, instead of running the lottery, we get to randomly choose a person in the network to create a block without the expense of proof of work. DFINITY's random beacon is vastly more secure than proof of work. It is also much, much faster and is completely impossible to hack. Impossible to hack. So, as we said, WebAssembly is the first standard for software that runs anywhere, and it enables extremely easy interoperation between software systems because DFINITY uses the WebAssembly software standard, and because we have one standard that can be run everywhere and that enables any programmer to use it, we can have a much broader software ecosystem and much better interoperability between software elements. Part of what makes things interoperate better on DFINITY is that it's a single computing environment, whereas in the case of the Alibaba or eBay seller, all of these systems are separate computers. So, the internet computer, it's just one computer that runs all of the software in the world. It's built from many, many interconnected computers. We plan for it to be over 1 million computers or servers connected together to create the internet computer. It's the first time anyone has managed to deploy a distributed random beacon. And it's designed to host websites, business systems, and store large volumes of data as well. We're used to blockchains being very expensive, or blockchain-based systems being very expensive. However, when you have a random beacon, everything becomes extremely cheap. The random beacon gives us a way to solve the scalability challenges of blockchain networks. So because we have millions of computers making up the internet computer, if some go down, that's okay. The internet computer will still be there and you will still be able to access it. Because we have something called cryptographic security as opposed to economic security, which is what proof of work has, we know that the computer can never be hacked. It is impossible for the internet computer to be hacked. The internet computer is not very secure, it is perfectly secure. Because we have this single, because we have a single hosting platform, systems that are running on the internet computer can interoperate very effectively. And this is the internet computer running. This is the number of nodes in this test of the internet computer, 600. In DFINITY, we don't have a single leader to move the network forward. We have a committee that moves the network forward every block. At any time, there are a large number of pre-selected committees, and DFINITY generates a random beacon to let it select which committee moves the network forward at any one time. And this number is the number of committees that are active. The committees vote to move the network forward, and a majority of votes are required to move the network forward at any time, but not more than a simple majority. That is this number here. There are 100 nodes in a committee, and 51 nodes need to vote yes to move the network forward. These green dots represent the nodes in the committees every round, every block. And because DFINITY is so phenomenally efficient, we can have extremely fast block times. So compare this to, say, Bitcoin that has 10-minute block times. We have 1 3/4 second block times. As a side effect of the way the random beacon works and the cryptographic security that it provides us, we get finality. That means the impossibility of a state reversion every 2 blocks. So that means, in this case, 3.5 seconds instead of Bitcoin's 1 hour. After 3.5 seconds, you have a much greater assurance of security with DFINITY than Bitcoin can ever give you over 1 million years. And in this example, we have about 50 transactions a second, but in the network that we launch, we want to have 300 transactions per second. Because we are offering freedom from platform risk and hacking, developers only have to consider, and DFINITY is an automated system, developers only have to consider what the system they're designing does, not how it does it. So because DFINITY is an automated system, developers only have to consider what the system does, not how it does it. This means that businesses can focus more on doing actual business. Because these businesses don't have platform risk, they are more stable and thus more attractive to investors. Because we don't have staff, we expect that the internet computer, even though it's more expensive computationally, it will be about 75% less expensive than traditional hosting methods. Andy Jassy, who's the CEO of Amazon Web Services, made a quote one time, and he said that eventually the operating system becomes the internet itself, which is very different from the way things have been done for 30 years. Amazon Web Services and DFINITY, we both have the same vision. We're going about, DFINITY is solving it in a decentralized manner, and Amazon Web Services is solving it in a centralized manner. And so we think that we are seeing a competition between centralization and decentralization. We don't think that centralized services are bad. We just think that there is a differentiated value in decentralized services. We have an amazing team. Dominic Williams is our chief scientist and founder, and he invented all of the technology. Timo Hanke is our head of engineering, and he built much of DFINITY, and he created something called ASIC Boost, which was a software enhancement for Bitcoin mining. Ben Lin was one of the inventors of the cryptography that powers DFINITY. Andreas Rosberg was the co-developer or co-designer of WebAssembly. Manoush Movahedi was developing a system very similar to DFINITY, and we met her at a conference and she joined the team. And Manoush also writes our academic papers. And Martin Beasy was developing a system to connect WebAssembly to Ethereum. And while he was working on that, he decided to join DFINITY and work on that project inside DFINITY. That's it. So, DFINITY is a not-for-profit foundation. It's based in Switzerland. We conduct scientific research and we're building the network, but we're building the internet computer, but we also plan to provide support to businesses that are using the internet computer in the future. We have two ecosystem funds, one in the United States that is run by Polychain Capital, and another one in China that is run by Wangshan Group. We're hiring, so if you'd like to join the team, have a look at DFINITY.org/jobs, and there might be a role for someone with your skill set on the team. If you'd like to know more, you can email me personally and I'll happily get back to you. My email is arthur@DFINITY.org, and if you'd like more information, if you make the subject of your email autoresponder, it will just send you all the information there is on DFINITY in reply. And that's my presentation. Arigato.